after that, we'll be following up with obfuscation techniques. And we'll be discussing what is obfuscation and why you should do it, obfuscation tools, and we'll be covering some PowerShell, Python, and JavaScript utility of it. So before people get a little intimidated by seeing PowerShell, Python, JavaScript, because I do know that quite a lot of people don't know anything onto those three. Well, I mean, like a lot of people know onto them, but like as in terms of what's caught into or taught in the course load, pretty much everything that you will be seeing is like more of like basic in the utility. So all what you'll be seeing us is doing a few strings and a few commands. That's all what you'll really need. What mostly matters is just the methods that we follow. But you guys will pretty much know everything that you need to cover through there. Following that, we'll go through de-obfuscation. And what is de-obfuscation? De-obfuscation tools and de-obfuscation methodology. And then finally, we'll be discussing polymorphism. What is it? And some built-in polymorphic functions. So we'll start off with the encoding there.
Awesome. Thanks, Christian. Cool. So, my name is Pablo. I'll be talking about encoding, which is our first topic that we'll be covering. So, just a quick little rundown. My name is Pablo, one of the content creator teams. Today I will be covering encoding with PowerShell, Java, and Python. What I'm looking forward for, like what I'm going to be talking about, is an introduction of what encoding versus encryption is, and how it hides malicious scripts and payloads. And then I'll show you some basic examples that you guys can follow along, and some code that I've just pre-done already, just so you don't have to do the whole math behind it. And then I'll be showing you encoding and decoding code. So right away, first things, guess what is encoding? For some of you, especially for a lot of Sheridan students, you would get introductory to encoding within your first year of Java. Pretty much encoding and decoding takes many forms with communication, data communication, programming. For computers, which is what you guys are going to be dealing with, encoding is converting a sequence of characters into efficient transmission or storage. But once again, for a lot of you coders, don't confuse this with encryption and decryption, which is more focused on hiding and securing data, which you'll also focus on in your programming classes. So, how encoding is represented, like I said at the beginning, um, pretty much on the left I have encoding, and on the right, I have encryption. So on the left, encoding, changing data into new format using a scheme. Encoding is reversible, so you can once you encode it once way, you can decode it right away. This is usually used to preserve usability of data. Some examples of encoding would be base64 and Unicode. And for encryption, pretty much secure way to hide plain text. There are two types of encryption. Symmetric and asymmetric. Some examples are AES-256 and RSA. And for RSA, you will be practicing a lot of RSA in your crypto or in your algo classes. Just for those that are new with these terms, symmetric is where you only need one key. Where one key is used to both encrypt and decrypt the information. And for asymmetric, a pair of related keys, one public key and one private key, to encrypt and decrypt a message and protect it from unauthorized access. Finally, like I said at the beginning, how it's represented, I have three languages: Java, Python, and PowerShell. In Java, it's represented in data different is da- is data in different format to efficiently transfer information through the network or the web. In Python, represented through Unicode, and in PowerShell is ASIC 7-bit character or Unicode UTF-16 format, as well as big Indian byte order, which you'll also learn more about in your algorithm class in your second year, which I found really interesting and really useful for this section. So now let's try with Python. This is a quick demonstration where I've just quickly gone through it. So just quickly, what is base 64? All upper and lowercase letters, so all 26 letters of the alphabet, and the 10 numbers 0 through 9, and sometimes with the exception of the plus sign and the backslash or the divide sign, as some of you guys also would know it. On the right side, I showed you a chart of the kind of like what each letter means. Like I said, capital, lowercase, and then the numbers, and then at the bottom, 62 and 63 are your plus and divide sign. Just a quick little simple math, nothing too complicated, just how you convert it. You'll kind of cover this in your math class. How it works: take the ASCII value of each character in the string, calculate the 8-bit binary equivalent to the ASCII values, convert it to 8-bit chunks into chunks of 6, convert that 6 byte into the representative decimal values, and from there, convert that decimal value into your representative value. Like I said, this may sound complicated, but don't worry, I do a walkthrough in the next slide. So nice, simple. This is where you guys can help me hands-on. Nice, simple. You can try this with any example, but for this example, I thought it'd be fitting if I used the word Python. So let's take the word Python for example. If you look at the capital letter P, you go back to the chart on the right, you locate it, you get number 15, and then same thing for Y, you get 50, T, and so on. You spell out Python with the decimal with the base 64 value. Now, like I said from the previous slide, you now convert that into your 8-bit values. So convert 15 into binary, you get that number 0, 1, 0, 1, 0, 0, 0, 0, and so on. You do that for other numbers. Perfect. Now, quick reminder that remember, base 64 can only be represented into 6 bits. So to shorten it down, you just grab your 8-bit binary and just select 6 bits. So then you just kind of break off each individual value from your original one. From that, you get your 6-bit values and you convert those into decimal form. Uh, so now you convert it to decimal form, you get 27, 37, 52, 26, 6, 61, and 46. Now your goal for you guys is to locate those numbers on the right and tell me what you guys get. And you guys can drop what your final answer is in the stream's question chat. I'll give you guys like 2-3 minutes because this is kind of just like a drag and look kind of activity here. And if you have any questions, please feel free to ask. So I guess I'll just do one by one. So if we look at 20, 20 is U. So I guess there we go. So our first character is U. Now we locate for 7. Our second character is H. Um, After 7, we got 37. You locate for 37. 37, 37. 37 is um, L, lowercase l, not capital L. After 37, you go on to 52. Locate 52. You get, that's your first, oh look at that, that's your first digit. So we get a 0, and then so on and so on. Typically, this is where you get your final numbers. So I will drop what I got in the stream's question, the final answer. I dropped it in the stream's questions chat on the Discord. So yeah, this is just quickly simple encoding in base 64.
If anyone did that, did they get it?
Yeah, you can also do this with any. I just want you guys to save you like the converting rate because I know it's been summer. Some of us have been to school, so I kind of did the converting rate for you guys. But this is something you would do in your algo class, which is honestly isn't too complicated. It took me like 5-10 minutes, only because I had to refresh my mind on how I had to convert my values. So, but yeah, it's really fun. You can do this with anything, really any phrase. Later on, you guys are just gonna be doing it on your own operating system. So perfect. Now let's encode a string in Python. So in the streams question, I'm going to drop you a URL. It's just to download Python. Um, if you already have Python, that's perfect. You can use it. I will be sharing my screen. You can keep watching Christian's stream. Christian will just be streaming my screen, so you guys can watch what I'm doing. Pretty much, you're going to download Python. It probably take you like 5 minutes. Just remember, big reminder, when you install Python, make sure you click Add Python 3.9 to path. This is what's going to give you the idle selection just straight off the download. So I'm just gonna wait in chat, just making sure you guys get that because I don't want to get too ahead of this. Making
What
sure you
we'll
guys
do
are.
is what we'll do is for everyone who has Python installed, or once you finished installing Python, just put like a thumbs up or something in stream questions just to let us know you're good. There, it seems like most people are done. Is there anyone who needs a second still, or we'll give people like 10 seconds to say if they're good or not. If not, then feel free to continue.
So okay. Oh, stream questions popping up. I'm good. Perfect. I'm gonna assume that everyone else is good. Perfect. Once you open this up, you should get. Remember, in your Windows key, just type in. Oh, that's not how you spell it, Python. Python, and then idle. You can also just try idle, and then it should show up best match. Click idle. Open that up. Perfect. From here, you're gonna click File, New, and now you have an untitled version. That is exactly what we want. Now, I'm just gonna move it. I will leave it there. Perfect. The first thing you want to do, that's how you spell import, is import base 64. the first line you're gonna enter. And if you have some experience with Python, this shouldn't be too crazy. I'm not gonna get too technical. It's just a simple like hello world type of thing, how you did with your first Java 1 class. Perfect. So you import this. What you're gonna do from this, just to save myself some time, you're gonna do message equals encode message by Pablo. In this area, you can put anything with Python. Unlike Java, it's not very specific on how you put strings. You can put it in single quotes, just making sure you're consistent with your single quotes. So there you go. You created your first variable, message, and this message could have anything you want to say. Encode message by Pablo is what I had. Awesome. From there, the next line, you're gonna create another variable. And this we're gonna use some of the functionality with Python. And the one here is message.encode. And then with the encode, we're going to encode our basis. So in this one, I'm going to use ASCII. Type that up. Next, the next line, create another variable. So base64. So now we're encoding our message, which is for me would be encode message by Pablo. And you're just encoding that in base64. And finally, this is just for later on to decode it. And then all you want to do, same thing, you create your message. You create a new variable base64 underscore message, and then you put in your previous variable, which is your base64 underscore bytes, dot decode into ASCII. You're gonna click run. It's gonna ask you to save. Click OK. Test1 is where I'm gonna save it. Once I save it, click run. Awesome. Whoa, it's a little buggy. Just making sure it's okay. Perfect. You ran your first Python, and this is what you did. Your first string encoding. Perfect. And this is your code, or the message that you typed in encoded. Great. Now let's decode it, because now we want to see in case you do get just a message and you just want to decode it by yourself. So now the next thing you're going to do is you're going to make sure. So we're going to leave this open. Don't close it yet. You're going to leave this open, and you're going to put this message into a variable. So same thing. Copy and paste from anything that was in blue from the idle terminal, and put in a message, put in a variable. And from there, it's going to be very similar to our encoding, except of using encode, we're just going to use the keyword decode. I'm just going to copy and paste from previous. Like I said, same thing, base64 underscore bytes equals base64 underscore message dot encode. So we got our first little bit. And the next thing, here's the big difference, is where you're going to put the decode. So you take your previous message, which is whatever this mumbo jumbo may be, and you decode it. You save it, click run, let that run. Perfect. We printed out the message again because this is from the previous one. And then this is what we're looking for that's different, is the decode. So just in case I want to, comment this out, save it, run it, just for clearing. Perfect. We've decoded our message from previous. That was pretty much it for encoding and decoding. Nothing cool. I'll later get more into detail about this cool resource that I was showed to by Christian. It's called CyberChef. Um, Pretty much, this tool lets you encode or decode any source, and I'll get more in detail later on in the slides. But just so quickly, you would copy your input in here, and let me just do a fresh start. So here's our code. That's what we got from our message, right? You copy that in, and now, luckily, oh, thank you for the link, CyberChef. Awesome. You select which one's your favorite. Here I have base64. So we already have it converted in base64. Now we want to decode it from base64. So all you do is drag and drop, and bam, it decodes it into. This is just a double check to make sure that it did work and it did decode it properly. But yeah, that was simple encoding. Nothing crazy. Let's try another activity. Let's try it with this part. We're going to do encoding in UTF-8. So all we're going to do, similar to what we did before, I'm just going to create a new line here. Perfect. We're going to create a string, just Python. Thought it makes sense because we're talking about Python. create a simple variable like that with our string Python. From here, we want to print the string. So we're going to put the string is, and then kind of like Java, you're just concatenating your variables. You're going to put string or whatever you like, whatever you named it here in the at the beginning when you initialized it. From here, um, we're going to take one of Python or one of this Python's functionality, which is the default Unicode. You're going to create a new string, string.utf equals string.encode. Similar to our previous one where we did base64.encode, this is going to be the default because the default encoding, if you don't initialize what it is just UTF-8. So, and then kind of like before, let's print the results. So we're going to print results. So print, the encoded version is string UTF, which is our variable here. Let's save it, click run. Awesome. So this is, oh, whoops, my bad. Let me comment this out just so it doesn't get too crazy. Run, save. Awesome. The string is Python. The encoded version is bpy. And see how it added character and single quotes. So cool little thing. You can also practice with UTF. Like I said, this is very simple, not supposed to be too complicated. Um, a cool little fun program that I found really interesting that helps me really practice your basics for encoding and your UTF encoding. Um, Perfect. So, um, you guys can go back to Christian stream. We're just gonna continue from there. I think those are all the visuals I have prepared. Um, Perfect. Next, how it hides the data. Now that's where you're gonna try it on your own. Um, I'm just gonna ask. You know what? Yeah, it's okay. So now let's try it. So now you're gonna try it in PowerShell. Um, Christian, are you okay with open up your PowerShell? Perfect. Thank.
Yep, I can get mine up. So also before we begin, I just want to ask, is there anyone here who's using a Linux or Mac system right now where they might not or may not have access to PowerShell?
Yeah, that was the next question. Just making sure that we all have accessibility to this.
Because for anyone who may not have access, so if you're like running a Linux system or something, you could try to use this resource as well. That should fix that up if you try that one, because it pretty much this one is just an online interpreter, so that'll do everything that you need it to do. Oh, that's right. There is also modules depending on how updated you are with your computer. I believe a lot of modern like Debian and Arch systems should have compatibility, but I'm not too specific on it myself. I know I have used it before on like the newest versions of Kali. I'm just not too familiar with it.
That's cool. I didn't know Linux had modules for it.
Yeah, surprisingly, Microsoft has been really nice with the Linux recently, which is good. Hopefully, we see more of that. Christopher also saw that you were typing there. Everything good there, or
I want to make sure everyone's okay. The first little bit was just Python encoding a string. Now we're going to do a little bit of PowerShell. So here I've listed out the commands that we're going to be typing them out. So let's try it. So first you're going to create your variable $text, and then you're going to put, I thought this is clever, this is a secret and should be hidden message. Once again, you can put anything you want inside the single quotes. Just make sure you're consistent with either double quotes or single quotes. Um, After that, you're going to create another variable called $bytes, and this is where you use the PowerShell command, so system.text.encoding, and you're going to use Unicode to get bytes of your previous message. So therefore, it's grabbing every individual character from your previous text variable. Um, Once you've all typed that out, the next one is, this is what we're going to do. This is the cool part. This is what I really found interesting, is where you encode the text. So once again, create your encoded text variable, and then this is like the key function here is the bracket sign convert to base64 string, and then your previous variable. And then from here, all you're going to do is just, there you go. Yeah, I was going to say convert. Awesome. There you go. So make sure everyone's got no errors. If you're looking at Christian stream, it was just a spelling mistake, nothing too serious. And lastly, you're just gonna print it out. And then you're gonna print out your variable, encoded text. Perfect. Once you typed it out, you'll notice that your previous message, this is a secret and should be hidden, or whatever you typed, it could have been like your name, your favorite food, anything would have been converted. So there's one really cool way how it hides its data. What we saw happen, we created PowerShell variables, used PowerShell commands, and encoded our own message in base 64. Now let's decode our message. So now, what you're gonna do is go create another variable called encoded text equals the print message. So this is like how we did previously. Remember how I said copy and paste the blue text from your idle? You're gonna do the same thing. Oh yeah, in case you cleared your screen, you may have to run the previous command so you can uh, see what it typed out. And with PowerShell, you can copy and paste. Yep. Yeah, this next bit's a little bit long, so I'll just walk you through what the command is actually doing. So you're doing previously like how we did in the second line for encoding, we're doing the system.text encoding. This time we're grabbing a string that we've converted, which is what we did previously, and we're pretty much just converting it from our base 64 string back to its regular text. And once you finish that line, you're just gonna print out your decoded text, and from there you should get the previous message we created in our first half of this um example. Pause here, see where everyone's at. Right now we should have a encoded message, and now we want to decode this message. Nice simple PowerShell. I think you may learn this in your operating system classes.
Haven't done that yet, but maybe.
I don't think I've done this PowerShell in the computer programming diploma. That's why I got a little bit of experience with PowerShell because we did do a full Linux class. That's why I'm kind of familiar with PowerShell, but I don't know if ISS has changed anything with PowerShell. I was still under the influence that I thought Python was substituted in for a C course, but I may be crazy.
Yeah.
Is everyone good so far? Just give us a thumbs up and stream questions and everything.
Well, like that Abdul
And
reaction made
if
us.
anyone if anyone needs a second, just let us know.
Awesome. I think we're good. Perfect. And then the last little bit, you just print out your message, your decoded text, and it should be your previous message that we did on our first little bit, where we encoded it. And if you see from Christian Stream, it says this is a secret and should be hidden message. So therefore, awesome, it worked. What happened is we decoded our base 64 text back into regular text form, so we were able to read it. Once again, none of these examples are too crazy or too complex. Just trying to keep it simple, very introductory course. Now, what it looks like a little bit more crazy. This is a Cobalt Strike payload. Um, this is something that you will definitely learn a lot about in your forensics class. Maybe not so much Cobalt Strike, but definitely with reading files, reading hex, and looking for malicious code. So for example, in this screenshot on the right, it's also taken from the Cyber Chef from a Cobalt Strike. And you can see that in the output, you see a lot of hexadecimal value, but on the right side, you do see some legible English. And that's kind of what we're going for here, is to make sure, because with your forensics class, I know that I can have your second years that you're going to be taking, you'll be practicing a lot of forensic and reading hex files and trying to convert into regular English legible, I guess, sentences that I really enjoyed. I did really enjoy the forensics final project where the teacher pretty much just gave you, hey, here's a file, you can't read it, try to figure it out. Definitely enjoyed it. You'll definitely get more hands-on on what this looks like. But here, what we can see hidden data inside the hex value. On the right side, you can see this program cannot be run in DOS mode, which is just right away, just by looking at letters and numbers, you wouldn't be able to read that. But thanks to ASCII, we can make some legible words and sentences from it. Um, Finally, just to make sure, so once again, some awesome resources. I highly recommend you play around this. I definitely did, like, for the last couple of days. I definitely just played around a lot with CyberChef. What is it? It's an online tool, free to convert any data. I'm pretty sure Christian dropped it in the chat. What's it used for? This would be really useful for your forensics and algorithm classes. I'm not saying you should use it. I do definitely encourage that you practice it. Um, but but yeah, like, awesome. Yeah, Christian could show you a quick little rundown. You type in a message, let's have fun with CyberChef, and on the left side you can select your operations. So here you're going to convert to base 64, and then on the output on the bottom right, you can see that your message has been converted to base 64. Now let's decode it. So now you select the same thing. You can also mix and match. You can do like to base 64 into hex, but for this we're just going to keep it consistent. Base 64. So now let's decode it from base 64. You drag and drop your base 64, and with CyberChef, it decodes it back to the original output message. Highly cool, highly recommended. This will definitely be a very useful resource, especially for your forensics class or your algorithm class when you get RSA keys and a bunch of hexadecimal keys. But they do have a lot, so there's Morse code as well. If for some reason you want to mess around with more Morse code, there's also XOR, which you will be messing around with in your algo class. But yeah, highly recommend. This is really cool.
Does anyone want to play around with CyberChef before we start moving on to our next part, or everyone thinks that they want to move on? We'll just we'll let you guys just post in stream questions. I guess just say if you just say CyberChef, or just say you want to keep practicing with if you want to, but otherwise we'll move along. Seems like everyone is good so far, but we'll give everyone. All right, sounds good. We'll start to move along then.
But that was encoding. I hope you guys enjoyed. Please, if you have any questions, please feel free to drop it. Any of the content creators are free to help. Next on to our next topic.
All right, so now we're going to start getting into the really juicy stuff, which is obfuscation techniques. This will be presented by Jackson and myself. Pretty much we're going to be covering it in Java, Python. Well, actually, we won't be covering Java. We'll be substituting that with Python, JavaScript, and PowerShell. We'll be talking about common techniques, measuring effectiveness, advantages, and disadvantages, example of obfuscation tools, and we'll also be talking about PowerShell obfuscation, and then we will be moving on to Python obfuscation.
Okay, can everyone hear me?
Yep, you're good.
Okay, just making sure. I just swapped my laptop. Okay, okay, yeah, next slide.
So the first thing that we have here is we have a bit of a challenge for all of you guys. Example 1 on the left side is unobfuscated code, and example 2 on the right side is obfuscated code. So now what I want you guys to do is in stream questions, I want you guys to describe how the first script works. I want you to describe what the second script does. All right. So yeah, you guys are right. So pretty much with the first one, what it is it has light switch status, which is true, and it'll loop that 30 times. For it loops it 30 times. If it's true, it will print the lights flicker on, and then it'll set it to false, and then it'll loop again, and then it'll print the lights flicker off, and then it'll set it back to true. So actually, it is not the first. It is not the first one. That is a very separate program. I want to see if anyone can figure it out. Um, we'll give a. Let's see. All right. If is there anyone who still wants to try to solve what the second example is? Give a thumbs up if you want to move on. If you want to work it out still, I'll just put a message saying wait or something. Ooh, looks like someone might have solved it. I see. You are correct. It is literally just a print statement. In particular, this program literally will just print hello world. So despite the fact that example 2 is more simple and it's in, the quality of it, it's because here's the thing. Example 2 is literally just a print statement, and example 1, has an if condition, it has loops, and it has an actual logic to it. Example 2, on the other hand, is just a print statement. But this is what makes obfuscation so dangerous for blue teamers and why they need to watch out for it. So for those who don't understand the code, pretty much we have an array here with just a whole bunch of letters and symbols, and then we also have another one just string there. And what execute does is it'll actually execute a string within there. So in this case, what it's doing is it's picking up a whole bunch of characters. So if you see v1, you'll notice that the index 1 is p. If you go to v4, you'll notice that it's r. If you go to 9, you'll notice that it's in. And then if you go to 7, you'll notice that it's t, and then it starts to go into the brackets and everything, and it starts to construct a print statement. So yeah, exactly. So Abdul said, I didn't even attempt to read it because it looks scary. And here's the thing: that's what makes obfuscation such a dangerous thing. It's just broken apart, and it's made to be as illegible as possible. And as you can imagine, for a lot of antivirus solutions or malware detection, this is crucial to be able to unpack, because you can't just look for because what happens with a lot of detection, what they'll do is they'll look at the assembly of it, or they'll try to make it so, for example, like JavaScript or PowerShell, which is run locally, you're able to just straight up see a malicious spring if it's not obfuscated anyway. So by using obfuscation, not only do you make it harder for a user to understand what you're doing, but you also make it harder for security professionals, and you make it harder for automated tools to pick it up. So we'll be pretty much covering how to make your code looking like this to something like this.
Okay, so now just a quick overview on obfuscation. So, kind of like Christian said, the purpose of obfuscation is to make code more difficult or impossible to understand. So this is done to prevent reverse engineering or to protect intellectual property. So if I, as a company, release some software and put it out to the world to sell, I don't want people to look at my code, reverse engineer it, and sell it. So I would obfuscate my code to make it harder for them to understand and replicate. So the obfuscated code should be able to compile and run and give all the same outputs. So that's where it's different from something like encryption. So software languages which create intermediary level instructions are usually easier to obfuscate, but the ones that come out to machine code are usually harder to obfuscate. So an example of the first one is like Java. An example of the second one is like C++. Okay, next slide. So now we're going to talk about some common techniques for obfuscation, and I'm also going to show some kind of examples of what it would look like. So what I found with these is they're all like kind of simple techniques, but where it really gets effective is when you put a bunch of them on the same program. So the first one is instruction pattern transformation. Basically, it swaps out common instructions for more complex ones which act the same. So it might do some more, do a bit of a different loop, some different arguments, stuff like that, to make it more complicated and easy and harder to understand. Next one is dummy code insertion. So basically, it adds code to confuse the readers. It doesn't really change the output in any way. So it might assign some variables, do some strange math operations. That doesn't really affect the program at all, but it just makes it harder for you to understand. And especially if we encrypt or encode our to obfuscate, then it'll be a lot harder to figure out what is dummy code and what isn't. Next is metadata or unused code removal. So it removes anything that doesn't affect the program, but that may offer insights. So it's kind of like if a reverse engineer is a detective, it's like we're trying to get rid of all unnecessary clues. So they can't read into anything and then use that to figure out what something else does, and then kind of unravel it all. The first one's pretty simple, renaming. So basically it goes through and it alters the method and variable names and often uses unprintable or invisible characters. So obviously, coding 101 is basically you should give good variable names and function names to help yourself remember what they do and remember where that then goes. But with this, it kind of It's that. So it'll go through your program. It'll swap things like, in this example, calculate payroll with just something like A. And then all the variables for just letters. In a lot of the more advanced cases, it would swap them with long strings that include different weird characters or invisible characters. But this one's just a simple one to show you. And then the next one is control flow alteration, which alters code to make it look like spaghetti code, which makes it unstructured and difficult to read. So if you look at the two programs, it's pretty obvious that the second one was a lot harder to understand. And yeah, on to the next. Then here's a fancy sounding one. So there's opaque predicate insertion. So predicates are basically statements, usually mathematical, are either true or false. So opaque predicates are conditional branches. So, okay, I see the question from Abdul. So normally, the way these programs do it, scrambling the code doesn't have that big of a performance hit on the program, and it's usually kind of mitigated by some other things I'll talk about later. Yeah, so like I was saying, opaque predicates are conditional branches, so like an if-then statement, and then they kind of insert these to make it difficult to determine results. Next is anti-debug. So this uses these use tools. These ones actually add code to it, where it helps you determine whether someone is debugging the code, which then, because debugging is often used to gain information, which would then help with reverse engineering. And similar to that is anti-tamper, which detects if the code has been tampered with and stops the execution if it has been. So a lot of the time these measures would actually break the code and make it unable to run. So then they'd kind of lose their copy in a way. So the next one is code transposition, which is pretty much reordering routines and branches, and basically reorders the code to kind of a non-logical way that still works, and it doesn't affect the code. Okay, next. So here's some more with examples. So the first one is string encryption. So basically it encrypts the strings and only restores the values needed when you need to run the program. And then that makes it difficult to search for certain strings. So for example, if I'm using a program that we use a URL or some certain password or certificate, let's say, that's stored in a string, I would encrypt it. And then when they look in the code, they would just see some weird letters and not the actual information. So as you guys can see, it doesn't change any of the actual code. So it still says messagebox.show, but the inside of that is completely different. Okay, so the next one is packing. Packing is where you take out basically all the spaces, all the enters, and you make your program compressed as it can within the document. So it makes it a lot harder to understand. When you have a really long program, it really helps you to be able to scroll through and realize, okay, this is where this function is. This is where this variable is, and so on. But when it's all scrunched together, it gets harder to look at. And harder to read. And with this kind of thing, even if it doesn't make it impossible to read, it still will slow them down. And often it's included with other stuff that would change around what's shown. Okay, next. So now we're talking about the measures of effectiveness for obfuscation. So the first is strength, which is how well it resists the attempts to reverse it. Then differentiation, which is how different the new code is from the old. And it also measures things like the amount of predications added, as well as like dummy code and anything you add. It measures that. Next is cost. So how much is it going to cost in terms of processing time? Also, how much it's going to cost in terms of cache. Because not all of these obfuscation solutions are free. Some cost money. Then there's complexity, where, like I said earlier, the more of these techniques you use, the more secure it will be. Then distraction. So basically, how confusing is it to look at a reader? How much does it give the reader a headache? Because that's also what you want to do. If they look at it and they say, I don't want to look at this, I'm going to go do something else, you've won. Okay, next. So now some advantages and disadvantages. So the first one is secrecy. So it hides the valuable information hidden in the code, but it's kind of a double-edged sword, because attackers could also hide malicious code that could be hidden. Next is efficiency. So a lot of the time it removes some unneeded code, which then reduces the amount of resources needed. Next is security. So obfuscation is built into your program, which then makes it good for use in an untrusted environment. So if someone opens it in an environment you don't trust, still pretty good to use. But nothing's perfect, and obfuscation is not perfect. So there are some disadvantages. So just like obfuscation can be used to protect code, it can also be used to protect malware. So if it makes the malware a lot harder to read, you might not realize it's malware, and you might have a lot harder of a time figuring out what it actually does. Can make your code more difficult to read and edit, and it adds time and complexity to the creation process. And a lot of the time it's not perfect. It doesn't make the code impossible to read. It's always possible to deobfuscate it. A lot of times it's just difficult and time consuming. And also it also adds extra costs onto your project if you're going to use a paid service. Okay, next. So
All
now
right.
Christian
So
is going
now we're
to PowerShell obfuscation.
So now what we're going to do is we're going to actually start looking at a lot of the manual workshop stuff, a lot of the reason why everyone came here. So for PowerShell obfuscation, what we're going to do is we're going to start up using both the Windows PowerShell ISE. This is pretty much just if you use the ISE, which I will open up for you right now. What you can do is you could pretty much just save all of your scripts onto here, which will be useful for if you just want to inference them later on. That'll be perfect. So unfortunately, if you do decide to go with that method, what you're going to have to do is you're going to have to set a specific command. This is because Windows does not like people running PowerShell scripts by default, and that's mostly just because there's no reason to. Really, only PowerShell scripts are mostly if you're planning on doing administrative stuff. So what you can do is if you want to fix that is you can do set execution policy to remote sign. That means that only anything that's trusted will be ran. I already have mine set to remote sign, so I'm just going to hit no here. But if you do, press A to yes to all. So whenever you're done with using PowerShell scripts, it's usually advised that you set the execution policy to restricted. This so that way you don't actually have to worry about, for an example, a malicious macro document activating itself. Once everyone is good, after everyone set their execution policy, just give me a thumbs up. You don't have to set it if you plan on just doing everything through the PowerShell terminal, but if you want to use ISE, go ahead. Yeah, it might deny you if you do need to run it as admin to do that. So in order to do that, what you could do is you could just search for PowerShell, and then you can run as administrator right off of there. You can also right-click it, and you can also run as administrator. You do need to run it as admin. All right, does anyone else need a second to run it, or is everyone good now? If you need a second to run it, still just type wait in the stream questions. All right, I'm not seeing any wait, so what we will do is we will start to continue and start getting into the good stuff. All right, so invoke expression. This one is a really fun command for sure. It's one of the most useful commandlets in PowerShell for obfuscation specifically, if not the most useful one. Invoke expression reads strings to look for commands. If they exist, invoke expression will run them. An equivalent is execute in Python, which we will be discussing later on. So what we're going to do to begin with is before I even run invoke expression here, what we're going to show is for those who aren't familiar with PowerShell, the commandlets are pretty much anything like write output. So if you want to do something like this, it acts as like a print statement pretty much. Commandlets are pretty much just PowerShell's way of executing commands. So the thing is, though, is if you do something like let's say you wanted to, I don't know, we'll make up an imaginary command here, and we'll just say we'll call it delete everything, and we'll just assume that it will delete everything on your system. If you try to run that as a string, obviously it's not going to work. However, invoke expression goes around that. When you use invoke expression and you use it on a string specifically, what happens is it will actually interpret it as a command. So what we can do here is, oh yeah, also make sure that you have your spaces right. Normally, what I like to do is I like to do quotations on the outside and then single quotes on the inside of it. But what you could do here is we will do invoke expression hello world. And then when you run that, let's see, where did I screw up here? Invoke expression. Oh, that's because I did invoke expression. I am losing my mind today. All right. So if I do write output, then it will work. But that shows as well. And yes, you can also, instead of doing write output, you could also use echo as well. So as an example of that, you could just do this, and that will work essentially as write output. So once everyone is good, you can. Does anyone need to wait on that, or is everyone good with that so far? Seems like I'm not seeing any wait, so what we'll do is we'll continue here. So in order to assign a variable in PowerShell, what you need to do is you need to start it off with a $sign. So the reason why I'm bringing this up is because this is what brings it up to what we saw earlier with the obfuscated code, which is string concatenation, and it works perfectly fine with the command. So what we're going to do is we're going to set a variable here to the letter O, and then what we're going to do is we're going to follow up with that by doing invoke expression, and we're going to do write. Actually, before we do that, what we need to do is we need to put in curly brackets. That's because in order to get this interpreted as one line, we need to put brackets around it for PowerShell to recognize that. If you try to do it without the brackets, what's going to happen is it's going to just go with the first string and it's going to ignore the rest of the concatenated string. So what we will do here is we will start with a double quote, do write, and since we want to add the O, what we're going to do is we're going to add with a plus sign, do our variable, plus sign again, and then we're going to finish up the rest of it, which is ut put, and then hello, and then finish that one off. And what we will see happen is it will actually print. So this is just like the very most basic version of concatenation with invoke expression. Anyone need a second still? So pretty much every time I'm going to say anyone need a second, if you need a second, just type wait and we will move on. Or if you need a second, just put wait and then we'll give it a second. All right, I see someone is typing. Right, perfect. For anyone else who's also using the web version of it, is there might be, is there any complications with it so far? Or is it running as expected, or as it should be running? All right, perfect. I think there's only going to be one case where you might get something a little funky that shouldn't be happening, but you can fix it by just rearranging a few things. I'll get to that shortly. So just to see how many people have cover. Okay, perfect. You're set. All right. So what we'll do is we'll move on to the next one, and we will do invoke expression and we'll continue talking about it. So the thing is what you'd assume with invoke expression, you'd assume, okay, so it just works with commandlets. That's cool. However, that is actually just not the case. What you can do with invoke expression as well is you can also actually perform operations. So what I'm going to do here is I'm going to do a is equal to 2, and I'm going to do b is equal to 3. And what I'm going to do is I'm going to type invoke expression. I'm going to put it in here, a plus sb. And I want to just see let's see what your guess is. What's going to happen when I do invoke expression a plus b? So you could just put your response. Yep, you are correct. It will output 5. So it'll actually do the operation as itself. So if you didn't have, so in a lot of cases, this wouldn't work, but that's important because of the fact that invoke expression actually allows you to run operations as well that way. So what we can do is we'll give everyone a second here. Is there any other operations you guys think that we could do as well when we do this? So give me just an example of what you think is going to happen. What's the point of invoke expression? So the thing is with invoke expression is let's say we'll go back with this one over here. When you try to, I mean, I don't think that this isn't exactly like the best example since it's a string, but what'll pretty much happen is if we try to do this with just the string itself, all what it's doing is it's actually just reiterating the string here. So this isn't actually being run. It's not anything useful. I'm just using it as an example. But the thing is with the string, is it's just reading it back as a string. It's not actually performing any actions. But when I do invoke expression, what it does is it'll actually interpret this as a command and it'll execute properly. Oh, why would we use it? So are you talking about in the sense of obfuscation? Or are you talking about like what's the practical reason for using it? Like outside of malware? So pretty much the reason why it exists is for example, if you want to have like a limited like remote access or something like that, what you could do is if you need to have something that allows you to have some flexibility with commands. So if you want to have a program that allows you to go into a shell or something, invoke expression would be perfect for that. In the case of obfuscation, by adding this extra layer, you make it harder for something to detect it as malicious. So, because when you go down to when you go down to like the runtime of it, pretty much, this is very different from just having write output. And when you're able to add all these strings and all these different stuff, you're able to make it look completely unillegible, and you're able to make it a lot harder for antivirus to detect it. Yeah, it's definitely a nifty little thing, but it's flagged as usually something to have your eye kept on just because of the fact that it's this powerful where it's able to hide. So for example, let's say if you wanted to do we'll look at like RM from Linux. Let's say you just wanted to have something that deletes your entire home directory. Instead of just having it execute that at a command line level, what you can do is you can go through your so like we'll just say that this will execute everything. This will delete everything in your directory. When you have something like invoke expression or you have like equivalent of that, you're able to actually hide just a command that just straight up says that into something a lot more obscure, which makes it harder to break it down. So what we'll do, is this a practical example if I want to get 80? Yeah, so that would be a practical example of it pretty much. So Kevin W put invoke expression, get 80 users. So if you just wanted to have it with like limited functionality or you wanted to have something that that would require you to put in commands, but maybe you don't want to do it at a PowerShell level, invoke expression could be used for that. I'm pretty sure there's a lot of other ways around it, but the thing is like it's a very niche in what it's being used, and most of the time that you see something like invoke expression or execute in Python, it's usually not for good reasons. But that doesn't mean necessarily that every time it's used that it's malicious. But you should definitely keep your eye out on it because a legitimate program will, execute what it needs to execute, and it doesn't really go through the effort of trying to hide it because it doesn't really need to. But for malware, they will usually try to hide it, so they will use these commands to get around that. Any other questions about the invoke expression? Or everyone good so far? All right, I'm not seeing any typing, so what we will do is we'll move on to the next one, which is syntax. Many commandlets like invoke expression have a short form as well. So actually what we did cover one of them where Kevin brought up the idea that write output also has an alias of echo. So for example, if you do something like write output hello world, and then if you do echo hello world, they both execute the same thing. They're the same command. The only difference is that echo is a shorter version of it. Um, So you guys are probably tired of writing this entire thing every time. The good thing is that there's an alternative around that, and that's IEX. IEX is the short form of invoke expression. So what you could do is if you were to do something like write output hello world, um, it still runs exactly the same thing because IEX is just an alias of invoke expression. It's just a short form of it. To save ourselves some time, we're pretty much just going to stick the rest of the time using IEX as well. But something that's also worthy to note is the fact that aliases allow you to do multiple ways of writing your code. So you can have multiple invoke expressions. You can try to obfuscate that code itself, but you can also use IEX as well. Another thing that's important to know is that when you see something like invoke expression, let me just get up. So if you try to do something like invoke expression, you can kind of like invoke expression may not be the best example of this, but pretty much when you look at it, you can see that you can try to make out what it is. Actually, the better example that we would use is get command. Get command, as it says, it gets a command. But the short form of get command is GCM. When you just see GCM, you don't really know what it is without like actually knowing what the command is. Because a lot of the time, if you're going through something, let's say a malicious PowerShell or a malicious Microsoft Word document, you can kind of skim through it. And if something catches your eye, you're able to usually just say, okay, I know what that does. I know that's malicious. But if it's in a lot more compact version of it, that makes it harder to interpret. So what we will do is we will move on from here. And another quirk of PowerShell syntax is the fact that it's not case sensitive. So, when you're putting write output in, let's say, hello world, you don't have to necessarily stick to using it. If you want to do it all lowercase as well, if it wouldn't just automatically do that for me, what you could do is you could just do something like this, and that works equally as well. What you can also do is you can also do what I like to call SpongeBob case, where you could do something like this, which makes it a lot harder to read, but it also actually has a practical benefit to it as well. Um, we will be discussing what the actual practical version of this is, but by also using by using like again SpongeBob cases, I like to call it, is you can also make it harder to read code because a lot of it just makes it harder to read. It makes it look more intimidating. You want to make things look as less English as possible, essentially. The less English it looks, the less legible it is, which makes it harder to deobfuscate. And by adding that intimidation factor to it, you might discourage people from going out of their way to try to figure out what it does. Does anyone need a second on this module still, or are we good to move on for now? Just hit it with a wait if you need a second to practice it. All right, perfect. I'm not seeing any waits, so I'll move on here. Like many other system scripting languages, or even just languages in general, like Python, Bash, PowerShell also has special characters that can be used in text settings. They can be activated through the use of the backtick character. It's usually you'll find it with the tilde character on the US English keyboards, typically on the top left of your keyboard. Some notable special characters are just the tilde or the backtick itself. If the character character that's following this, so let's say 0 or A, as an example, if the character that's following that is not reserved for, I guess just to explain this better is most people will see \n. A lot of languages interpret that as new line, but if you do something like let's say \5, most languages that doesn't mean anything. The same thing applies with this, where if you have backtick A, that will be interpreted. In PowerShell, let's say capital T, this is not existing. So if you have something like capital T, which doesn't exist, like \n does as an example, in other words, not a valid character, this will be ignored entirely. And this is important for obfuscation, and we will be discussing that briefly. What we also have is the null character. If you do something like that, what it will do is it will print a null character. So while it might seem like it's doing nothing, don't be deceived. The way that you can pretty much interpret null character is while it might not appear or show anything that's human visible, the way that you can read it is you can essentially think of it as almost like an empty array. It's just not visible to us, but it's still a valid character, so it's worthy to be noted that. And if you have backtick A, I don't think our online friends will be able to hear this one, so I will quickly share my screen over to this one. Let's see, applications PowerShell. And what you can do is you can actually hit backtick A, and you will actually hear the Windows noise go off. So, there's a few functionalities of a lot of these ones. So if you guys want to just play around with that for a second, feel free to, while I just quickly move back to the screen.
Got scared by that for a second. I thought my computer was dying.
Who knows? Maybe you got some obfuscated ransomware on your computer, and it just that's all what it's going to do. It's going to keep chiming the bell until you pay up.
Hope not. I don't have any
Uh,
Bitcoin.
for now. So what we will do is without the escape character, or using the, or so pretty much what we could do is we can have it like this. If I just write hello world, our normal way of doing it, nothing happens. But I want you guys to check this out as well. What you're going to do is you're going to put your backtick next to the L. You're going to put a backtick next to your comma here, and then you're going to put your another backtick next to the L. So when you actually run this, it will run perfectly fine. The reason why is because L, the comma, and L again are not valid escape characters. I'll be telling you what all the valid escape characters are soon, but pretty much in this case, none of these are valid escape characters. The same also works if you want to do IEX. So for example, if I do write output and I put that over here, put another one over here, and I do something like, I'll just keep hello world as it was, it will run. So even though that is technically breaking up the at least human readable, when you look at it, it's breaking up the command, but the thing is it's still executable because everything that is in here is not a valid escape character. So what PowerShell does is it actually just ignores it and it will let you run it as you want to. This is useful for obfuscation because of the fact that it actually makes it harder for something to detect it. Because, like, for example, if you have write output, but then you have a whole bunch of backticks there, something might not recognize it as a valid command. However, there is also something that you should note, which is if you do use it with a valid escape character. In this case, R, T, and E, these are all valid escape characters. But what happens when you do something like this is it will crash your program. Because of the fact that these are valid escape characters, it will interpret it and it will try to do what it's trying to do. So let's say T, for example, backtick T. That one stands for tab. So the way that it'll interpret it is if you just do something like that, is it'll actually interpret it as this, where backtick T gets removed because of the fact that it has to function the tab, or it has to do the tab function. So it also removes it as well, but it also just messes up your script. So it's pretty much interpreting it like this. So that will not work if you try to use an escape character or if you use a valid escape sequence. That doesn't necessarily mean that just because you use it, it's going to crash it. So for example, if we do IEX write output ABC, it will run and it will make your Windows alert noise. You guys can't hear it because I'm doing screen share right now, but you guys will notice, as I said earlier with backtick T, it will remove it if it is an escape character because it has to perform that function. Does anyone need a second on this one still while they mess around, or just hit with the wait again? Let's see. All right, nothing yet. So what we'll do is we'll move on. So something that's actually that also functions similar to this is the null character. The null character, if you do something like this, you might not notice right away that it's any different. But this is actually very different because the way that it's going to read it is the computer pretty much reads it as if it's like this, where the brackets will represent a null character. The null character again is not human readable, but however, it is still active in it. And you can test this by doing this with the command. So if we remove that and we stick it, let's say, somewhere in write output, what it'll actually do is it will crash your program because the null character is still there. The way that Windows would read it is it'll read it something like this. So for a string, that's not so much of an issue, but in the case of a command, that will definitely be an issue. If you're just looking to print your string or something, the null character isn't going to make a difference. But if you're actually going to try to run a command and the null character is present, it will break it because it tries to read it as a command. Unless if for some reason it decides to use the null character within the command, that's the only way it'll run. Let's see. With the valid reserve sequences, those are backtick 0, backtick A, backtick B, backtick E, backtick F, backtick N, backtick T, backtick U, and the little brackets, and backtick V. Anything that, if it uses any of those characters, it is considered a valid escape character and it will not work. However, if you change that to an uppercase as an example, and you do backtick A. So instead of, so again, as a reminder, that's with the bell chime because that's what backtick lowercase a is. But if you do something like an uppercase, it prints it with no issues at all. So if you remember what we mentioned earlier about camel case or the SpongeBob case where you can go uppercase and lowercase, if you wanted to put, let's say, a backtick in front of an A, what you can do is you can just uppercase it. It's going to be a bit of an issue if you're trying to do with a string and you need that to be put specifically. But for example, what we could do actually here is I'll put that back to normal and let's go see back to T. In that case, it won't run. But because of the fact that Windows is okay with very weird cases, it will run that perfectly fine. So that's just one way that you can obfuscate as well. I'll give people 5 seconds to put wait if they need it. Otherwise, we'll move on. Actually, what I will do as well is I'll actually send you guys a document in the channel that Microsoft uses for escape characters. So what I'll do is I'll just copy this one over here for you guys. And I will post it in stream questions. So if you want to find out everything, here, let me also just put the linked version so we can just click it. So pretty much with those special characters, you can find everything that you need to there. In case if you forget what they are, you can just look up on that resource and it'll contain every valid escape character. Plus a few other interesting things as well. Let's see, was I on the... Okay, perfect. So what we're going to do is we can also use strings to obfuscate text and commands. Before, all what we've done is we've just done it with commands that were inside of IEX. However, what we're actually going to do is we're going to obfuscate IEX itself. So what we're going to do is we're just going to do a var. We'll do E in this case. And if we do something like IEX, right? And then let's say we'll do var1 there. World. Let's see. Oh, that's because I messed up there. It is not var1, it is var. That will run as expected. But here's where we're going to change it up a little bit. Instead of doing what we've done already, which is, sticking a whole bunch of characters in there, what we can do is we can actually run the command IEX itself. In Windows, what happens is if you do something like this, which is the period and then followed by 2 brackets, this will actually interpret anything on the inside as something that can be run. So if we do something like I plus E, well, in this case, we're going to use var because that's the one that contains our E character. And then we do X, what will actually happen is Windows will interpret that and it will run it. So now you can start to see why this is starting to get even worse. It's not so much of a matter of just doing Control F and trying to find IEX or invoke expression. You can actually obfuscate the commands itself, which makes it even harder for something to detect it as malicious or detect if a specific method is being run. Because right now, if you just look at that first one, if you don't know if you just only know what IEX is and you didn't know about this functionality, that would just look like garbage. It wouldn't look like it does anything. But in this case, it will run the command. Also, something that's interesting to note as well, for our online friends, this might not work for you. You can actually rearrange it based on what it is, but with a lot of common stuff like PS home or profile, which are reserved variables, you can actually print out a lot of interesting things. However, with a lot of malware or with a lot of anything that's trying to be, that wants to run IEX, if you can also index it. So let's say if we do PS home 0, it'll print out C. If you do PS home, let's say 3, it'll print out W, because that comes from the C drive in the string, and then 3 comes from 0, 1, 2, 3, which is the uppercase W in Windows. But what you can do, and what a lot of software likes to do, is it likes to take advantage of these predefined strings. So for example, if we do PS home 4, PS home 15 plus X, and then let's say we'll just add write output here. It will actually interpret that. So for those who don't understand what's happening, if you search PS home 4, you get I. If you search PS home 15, you get E. So for most systems on Windows, PS Home is consistently usually C drive, Windows System 32, Windows PowerShell v1.0, because there's no really user directories in there. These are just system directories. If you actually run it with the online version, you will get a different one because this is run through Linux, but this one will be opt Microsoft PowerShell 6. you guys kind of rearrange them based on how it is to get that to run. If you're using a Linux if you're using Linux to run your PowerShell, or if you're using online to run PowerShell. But in the case of, like, let's say a Windows target, this directory will pretty much always be valid. Because even if you do use a different drive, for example, and you decide to use X, it still doesn't change the size, and it still doesn't change any of the important characters, which are I and E. So you can start to see how this is getting more and more dangerous as time goes on. However, as we mentioned earlier, unfortunately, just because you have maybe let's say a hypothetical company, let's say they start to get smart about it and they start to detect IEX all the time. But one thing that they aren't prepared for is the fact that you don't have to necessarily use IEX to run IEX. In the case of get command, you can do just this. So let's say if we do if we combine get command with this, so actually just starting off with what get command is. Get command pretty much just searches for commands. If you try to do something like get command wildcard, what's going to do is it's just going to print all valid applications you have on your computer. You can start to close that up even more to get more specific things. So let's say zoom it, we wanted to get, it'll bring up zoom it, and it'll tell you the application version, source, etc. What you can do is, if you want to be really sneaky with it, is you can do GCM, which is the short for get command, and you can do EX, and you could do, oops, did not mean to do that. I'm just gonna have to take a second to do this. And what you can do is you can do write output hello world. So it executed similar to IEX. So why did it execute IEX? Because if you do GCM E-EX and followed by another wildcard, what it does is it pretty much searches for anything that matches this property, which is E-EX. However, there's only one command that follows that structure pretty much, and that is our good old friend invoke expression again. So not only what pretty much what's happening here is we're using get command to invoke expression, which then invokes write output. So right there, we pretty much already have a chain of 3 different commands just to print hello world. Because if you had just done write output, that'd just be one command and you could tell that right away. But using get command and using invoke expression, you've now added 2 extra layers of obfuscation to that. And so now when you consider things about like string splicing, breaking apart that string, this will look like complete gibberish to someone who doesn't know what to read. Any questions about this part of it so far? All right, I'm not seeing any typing, so what we'll do is we'll move on here. And we actually have a mini challenge for you guys. So invoke web request is a very useful command in PowerShell, which pretty much you can get information about a web page. So let's say if we do https //www.google.com, what it'll do is let's see. Well, okay, let's see. All right, the remote name cannot resolve google.com. I'm going to try to invoke web request. Just give me a second here while I figure out if I just messed up something or if I'm just losing. Okay, yeah, I'm just dumb and I used the wrong. Wait, did I do invoke expression? No, okay. Invoke web request. All right, I'm not sure why it's working now, but it's working now. But pretty much what happens when you run this command, what you're going to do is you're going to find out all this information about google.com, which is the status code, status description, content of the page, in other words, the HTML part of it, the raw content, forms, headers, images, etc. Pretty much everything that you would need to find out about a web page. What you can also do is, let's say if we do get page over here and we do invoke web request, and then we do https //www.google.com, we can store that into our variable get page. When we do return status code, and we do something like get page.status code, what we can do is once we run that returned status code, you will find out what the return status code would be. In this case, what we're going to do is we're just going to echo what's inside of there, which will what it should do is it'll bring back 200. If you also want to do get page.content, you'll also find out the content of the web page, which is all this stuff. You can also do that as well by doing let's say get page, and we want to do the status code. You do that, and it'll return 200, which means HTTP's okay. So but basically what I'm showing you is just something that you might come across with a piece of malware, or as an example. What I want you guys to do is turn this simple 3-line script that I have here, which pretty much gets the page using invoke web request, stores it in the get page variable, takes the status code by doing get page.status code, and then displays the content. What I want you guys to do is in PowerShell is create a script with all of the lines that are above here, but obfuscate it. So just a reminder on everything that we covered. We covered the backtick, we covered string concatenation, we covered case sensitivity, aliases, get command. And I want you guys to do just a simple like 3-line script. And I want you guys to obfuscate the living heck out of it. So I'll give everyone like 10, 15 minutes. Whenever you're ready, feel free to just share it and stream questions. For those who don't know with Discord, what you can also do is you could do something like this, which let's say PowerShell as an example. What you could do is you could do get command. Let's say we wanted to do our good old EX here. What it'll do is it'll print that in a code block and it won't remove anything out there. So pretty much whenever you're ready, feel free to share it that way, and I'll be streaming in with everyone as well. So pretty much again, triple backtick, ended off with another triple backtick. Put whatever language you'd like to use, and there you guys go. So I'll give people 10, 15 minutes to create their own obfuscated page with anything that they wanted to. So I'll let you guys start that now. Feel free to start obfuscating. If you need help with any of the things that we've covered, feel free to just mention it, and I can go back and I can talk about it. Any questions before you guys begin? All right, I'm not seeing any questions, so go ham, guys. If you have any questions while you're working on it, feel free to let us know. All right, let's see here. From Abdul, we got A is equal to https://google.com, followed by IEX. Here, I'll actually bring it up over here. So what happens is you have variable G is equal to invoke web request, $A, and then you follow that by doing IEX again. So yeah, that would be a good example. So pretty much the two obfuscation techniques that you've used here is you've renamed the variables to make sure that they're a little ineligible, and then you've also used IEX to actually cover up the commands that are being used. So yeah, that would be a decent example of obfuscation. So what are your guys' thoughts on obfuscation so far? Feel free to also include some of the encoding stuff that Pablo brought up as well. All right, so is there anyone else who's still preparing? So I guess just to do a number check, if you want, just put a thought. Actually, what we'll do is so say wait if you still need some more time to obfuscate your code there. Just a check to see if everyone's done for the most part. Has everyone read in at least one example of it so far, or there's some errors that we can help out with so far? All right, so I'm not seeing any wait, so I'm gonna take a guess and assume that does anyone need any time? I'll just do one more check for that. Just type wait if you need some more time, but it seems like people are good so far. All right, going once, going twice, and sold to our next page, which we're actually going to go into intermission. So since this is a lot of stuff, take the next 10 minutes to take a break. While it might be too late for you to order some shawarma, it's absolutely not late for us to continue with obfuscation. So now we will continue.
Wow.
Amazing.
So pretty
So-
much now we're going to move over to Python obfuscation. So what I'm going to do is I'm just going to have everyone just kind of open up idle, or what if you have something else that you prefer, go ahead and open up that too. We're not picky. But just for everyone to follow along, I guess I'll just use Python. I'll use idle since this is the one that we've been using with so far. Actually, you know what? I'll just go with command line for now. I don't need to save any of these, so I'll just go with command line. All right. So what we will do is we will begin by talking about the execute function. similar to the previous module, much of the same concepts in PowerShell obfuscation can be applied to other languages like Python. So similar to invoke expression, Python's equivalent of that would be execute. So if we just kind of print, if we just run something like this, which is just a print statement in a string format, what we can do here is we can actually execute print hello world. So we go for, so, as we did with invoke expression, we're pretty much just turning our string into an actual executable command. And expanding on strings from the PowerShell module, we'll now go even deeper by using strings. One of the best ways to use splicing is with the use of arrays. Being able to hold multiple values and the functionality of both arrays and strings in Python can make for a complex obfuscation. So if you guys remember, what I'm actually going to do is I'm going to go back all the way over here to our first example that we got at, so over here. So pretty much with this one over here is this complex massive array is intimidating on its own because the fact that it's not single characters and the fact that it's just so compressed and you're able to add the additional feature of pretty much choosing indexes. By having the feature of indexes, you're able to make it a lot harder to actually follow along with this. Whereas if, like, for example, like A over here, which is just a comma, if you just look at that, you would know it's a comma. Whereas in here, you actually got to do the math to try to figure out which one it is. So what we'll do is we'll run all the way back over here, and we'll try doing some stuff with arrays. But what we're going to do is we're going to declare an array called A with P and E. And what we will do is we will execute, but what we'll do is we'll start off with A0, which would stand for P, and we'll add a string called rint just to complete it from going from rint to print. Once you're finished that, since the next part that we want to add is the E, what we'll do is what we'll do here is we'll do, oh, I made a small mistake over there. Make sure to double quotation everything. And then we'll add the E, which will be from A1, and then we'll finish off the rest of the string that we have here. And then it will execute. So pretty much it's similar to what we were doing with our most basic version of splicing. So the cool thing is about Python arrays is that you can also go with them in backwards. So what we could do is we can copy our first execute statement over here. And what we can do is we could do something like -2 and -1. And if we run that, it'll also run. So the reason why is that works the way it does is instead of going for index 0, what we're going to do is we're going to start on the other end. This is -1, and then this is -2. So -2 will grab the P, -1 will grab the E. Another cool thing about Python strings is that you can actually splice strings, and you can take advantage of these in a lot of interesting different ways. Right, I'm not using my terminal, I can't do that. But if I do something like var1, and I say I can't print strings, I now have a variable that has a message I can't print strings. But what we're going to do is we could do execute var, and we'll splice it from character 8 to character 13. And then what we'll do is we'll follow up with the rest of our hello world statement here. And what will happen is, oh, I made a mistake there by not calling it var1. That's just because that's how I initialized it earlier. But what we will see is after we execute it, is it will run as expected. So just a little interesting tidbit about splicing strings in Python is if you decide to use two characters, the first number will be inclusive, so it'll include the point that you're ending on. However, the second digit is exclusive, so it will not include the character that it lands on. So what you need to do is you need to usually just do whatever character you need to incorporate last. You just do that +1, because technically 13 would be index 13 is the space between print and strings. But because of the fact that it's exclusive, we need to add +1 to make it that point, so that way we can include the entire print statement. So what's really unique about this is you can have some innocent looking text or strings in your program, and you can actually splice that up and make it malicious. you don't necessarily need to use print specifically or whatever your command is supposed to be. You can just splice up multiple different strings to create that. Another thing that you can do to mix it up a little bit is you could also use format strings as well. So the way that format strings work is what you'll do is instead of just starting off your string or before you start off your string, what you can do is you can include F and it'll turn that into a format string. And the interesting thing about format strings is that you could do something like this, and that will be interpreted literally. It does make it a little bit harder or easier to read depending on the context of it. But if we do something like this um, with the format string, is we can insert our characters a little bit differently. Let's see. I need to finish that up. Let's see. Nope, silly me. I included print, or I included a P in my print statement there. So what I can do is I'll just go back here and move it as it should be. And there we go. It'll execute hello world. The thing is you don't necessarily need to just get stuck with just using one specifically as well. What you could also do is you could do something like this, where you can mix and match them. So let's say we wanted to do a format string first, and let's say we wanted to end it off over here. What you can also do is you could also use the regular string splicing message. You don't have so for every string that you have, as long as you started off with F, that'll be considered the format string. Anytime that you enter a new string, you got to redeclare it if you want it to be a format string. So what we will do here is we will go back to using our normal strings. Let's see, F string, undetermined string. Let's oh, undetermined string. Let me just fix that quickly. A string and terminated string. Oh, I'll try doing this with the let's see. Oh, that's why. Okay, I don't know why I have yeah, I see where my mistake is. So what I did was I forgot to close off my bracket here. There we go. That should fix that. There we go. Okay, yeah. So now that that's fixed and I have fixed my boo-boo, I'll move on to the next one, which is our second Python or our second script that we're going to be making. So what I'm actually going to do is I'm going to send everyone a file for a script that they need to scramble. If you have a really good memory, you might remember this from earlier. I have sent it in stream questions. Pretty much, this is just the light switch script that we saw from the beginning. And I want you guys to make it join its example 2 partner over there and one up it by making it obfuscated. So what you guys can do is you guys can cover literally everything that we've talked about. If you want to rename variables, you want to do string splicing, you want to pack in useless code. So let's say a plus 37 times 22 and never actually call it. You can do that as well. Execute, do string encryption and encoding, and being creative with it. Try out new things. So pretty much, I'll give you guys some time here to start obfuscating that. If you guys need any help, don't hesitate at all to say anything. We'll be glad to help you obfuscate and learn how to do all that. So I'll give you everyone like 10 to 15 minutes. Once you finish obfuscating, feel free to drop it in stream questions. The more that we're able to share our scripts with each other, the more we can learn off of what other people do. So I'll give everyone until like, we'll say 9:06.
I think we're good to keep going. It's getting a little late, so
Yep, we will get going again. All right, so I'll pass it on to Jackson now.
yes. So now we're going to be talking about some obfuscation tools. So these are usually websites or downloadable services that you can use to obfuscate your code. Okay, next. So this first one is pretty simple. It's the JavaScript minifier. So earlier we talked about the packing technique for obfuscation, and this is pretty much what it does. So you can see on the one side, you put in your JavaScript code, and then on the other side, you it gets rid of all the spaces and lines and all that. So obviously, it's still pretty easy to read this way. But if you have like a longer program, it would just look like a big box of text, and it would be a lot harder to read. Yeah, so there's the example. You guys can take a look at it if you want. We're more going to focus on this next one though. Yeah, Obfuscator.io. So someone can post the link there. I can post it. Okay, thanks. You're ahead of me, Christian. So I'm actually gonna start a stream right. If my stream quality goes down, I'm sorry. My streaming isn't very good. I don't know why. Yeah, so we're just gonna take a look here. So Obfuscator.io is a online obfuscation service where you put your JavaScript code into a box, and then you can basically do all sorts of different types of obfuscation to it, and you can change around a bunch of settings. Are you guys able to see my stream?
Yeah, Christian's streaming it on his device.
Oh, he is? Awesome. Okay. So yeah. So I just wrote like some quick code. It's like a hello world program with a few extra like just variables and then add the variables together. And so if we look down here, there's a bunch of different things we can do. So there's the identifier transformations, which is similar to the rename that we looked at earlier, where it changes the names of all of the like variables and functions, stuff like that. There's other transformations like compacting it and simplifying it. Dead code injection is kind of like dummy code. It's kind of like dummy code injection, and the 0.4 is how much. Pretty sure it's how much of a percentage you want to be dummy code. Then there's string transformations, which basically change everything else in it, and you can figure out how you want to do that. So with a string array, do you want to rotate it, shuffle it? It's how you want to randomize a string array. And then there's other stuff like self-defending and debug protection, which actually requires some more code. The fun thing with this I found was you can change it from like there are kind of presets. So you can make kind of a low obfuscation, obfuscate it, and then see what it looks like with high obfuscation, let's say, to see just what's different. So I just wrote this quick program here. So I know it's getting kind of late. I don't want to take too much of your time, but if you guys want to just try to make a quick little JavaScript code and look at how obfuscation changes it, I'll do a little bit here. So we can. This is just on the low preset. So even with low, it still changes it a lot, really. And then if we look at something like, let's say, remove compact and simplify, and then obfuscate the same code, it just gets a lot longer. And so you can see, like, even if most of it's still gibberish, not having it compacted or simplified, you can still kind of see some of the basic code layout. And you can kind of figure out how the program could work from there if you're skilled enough. And now we're going to try let's try with high. We're going to obfuscate it with the high option. And so, yeah. Now, like, let's get rid of compact and simplify again, just to see what it looks like as closer to code. And see it's a lot more gibberish. Or at least hard to understand. So yeah, this is a simple tool. It's free online. You can just plug your JavaScript in, take it out, etc. Okay, so I'm going to stop streaming now. So now I'm going to talk about some of the more like official services, like not just like a website that you put stuff in. Like this is actually like made by a company. So this is the first one's ProGuard, which is actually the service I was most recommended when I was researching obfuscation. It was actually a little annoying because I was trying to figure out how to obfuscate for myself, and it was just saying download ProGuard. So about ProGuard now, it's created by GuardSpace, which is a company with a bunch of applications focused on mobile app security. This one works with Java, Kotlin, and Android apps. I don't know if I'm pronouncing Kotlin right. Might be an acronym. So it's free to download and it's a command line service. It shrinks. One of its main things is it shrinks applications to be up to 90% smaller. And this shrinking then makes the apps up to 20% faster. So it actually improves the performance. The obfuscation for it, though, is pretty basic. It mostly obfuscates the name of classes, fields, and methods, and shrinks the bytecode of the code. So because of that, it's not really mainly an obfuscator. It's more of a code shrinker with a bit of obfuscation. So some other programs might work better for security. Okay, next. Christian, next. So next is JScrambler. So this one works with JavaScript. This is actually a paid service. And you can kind of, I think you have to get quotes for what you're doing it for, but it offers a free demo. This one actually uses polymorphic obfuscation to conceal, and with polymorphic, it basically gives you a different version every time you use it. So no two uses will be the same. What I found cool was it can lock code so that it only runs in specific circumstances or environments. So you can make it run only in a specific domain, operating system, or browser. So I can make it so potentially my code is only usable on company devices, on company networks, on the specific operating systems our company uses. You can also allow, just go back. So you can allow countermeasures which trigger automatically in certain situations to stop attacks. And those could like redirect an attacker to a different page or lock certain things or kind of break the code. Also detects debugging and tampering attempts and can, like I said, break the app to prevent attackers from accessing stuff. Also offers threat monitoring, which monitors a protected application for any possible threats and reports them to you. The next is PyArmor, which is a command line tool used to obfuscate Python code, which I'm sure you could have guessed. This one can bind the code to specific machines, which allows it to run only on those machines. It obfuscates the constants and literal strings of the program, and obfuscates co_code and literal strings. It clears the local frames once the program's been executed. It's also able to expire obfuscated scripts, which makes them unusable. And it's a free-to-use service, but is currently in beta testing. So now on to de-obfuscation.
All right, so pretty much with de-obfuscation, as its name suggests, pretty much doing the inverse of obfuscation, and you're actually disassembling everything. So the reason why we have to de-obfuscate is to restore the original source code of a program into readable form. By doing so, that's how we figure out the functionality of it and the purpose of the program. De-obfuscation is pretty much essential for anyone who wants to become a reverse engineer. Reverse engineering is equal to backwards engineering, which is equal to back engineering, which pretty much comes to what de-obfuscation is. Taking something that's in one form and bringing it back to and figuring out how it works. Reverse engineering is a process or method through the application of which one attempts to understand through deductive reasoning how a device, process system, or piece of software accomplishes a task. For example, by analyzing the .exe file without the source code, we can study how the program works. In this part, we'll try to de-obfuscate the code and use obfuscation techniques that were mentioned in well, we're going to take through everything we learn in obfuscation, we're going to de-obfuscate that. So pretty much, in order to de-obfuscate, first thing you got to do is you got to locate obfuscated code, and then once you've done that, you have to learn how to make it readable. What you can do is you can analyze the obfuscated code, and you can start to recover the high-level view of it. It's a time-consuming process, as you can tell, especially with a more complex example like Jackson showed earlier with I believe it was obfuscator.io. It can take an extremely long time. But the good thing is there's both automated approaches that you can do to taking it, and there's also manual approaches that you can do to solve it. So some examples, some tools that we could use is JavaScript beautifier. So pretty much what it'll do is it'll learn how to it'll look at something that might be compressed. So what we could do is in this example from the beautifier is we have a one-line function, and what it'll do is it'll space it out so that way it's not compressed. It also does a whole bunch of other things, but that is just like a brief example of it. What I'll do here is I'll post all three of those links quickly. So let's see, we have the beautify tools. This one's for JavaScript. Following that, there's also Prettier.io, which pretty much does the same thing. Personally, I prefer this one, but and then finally, there's also jnice.org, which is meant for JavaScript. So sometimes there's even very specific examples to decode something, or maybe people have gone out of their way to make a decoder for a very specific one. In this one, we're going to look at JSFuck, which, as its name suggests, it does that with the code. It makes it extremely hard to understand.
First half of the touchdown to Wilkins.
Thank you for that. So pretty much what we'll do is we'll look at the first example of this. So this is alert one, and what it does is it compresses it all the way down into that, which I don't know about you guys, but that does not look readable at all. But the weird thing is this is perfectly runnable. In order to deobfuscate it, you could use an obfuscator that was made or deobfuscator that was made specifically for it. I'll quickly just post both of those after I paste this in Notepad, just so we can get back to that later. What you can do is this one. I'll copy the link there. Nope, that's the code. So for JSFuck, there's the link to that one, and then for the decoder, I'll post this as well. And what you could do is once you enter the website, what you could do is you could take the malicious code that you got or whatever the code is, copy that, and when you paste it, what you could do is you could press decode, and it decoded it back to its original source, which is literally just alert one. There's also other specific examples that this could go to, which would be AA encode, which pretty much just turns your code into pretty much just a whole bunch of Japanese smiling faces. So what I'll do is I'll paste those ones as well for the encoder and for the decoder. So when you look at the encoder here, what we'll do is we'll open that up, and we'll go with the basic alert, hello JavaScript. So when you run this, it'll run exactly that. And then when we open up the decoder here and we copy the link or we copy the code that we got here, what we'll do is we'll copy this as well, open that, copy it again. And what we can do is we'll select all that, paste what we got, a decode, and then it goes back to its original source, which is hello JavaScript. The great thing is with the automated scripts or with the automated programs that you have online is that it saves you a lot of time and energy from something that was extremely strenuous, something that's a lot harder to decode, which would be this. I don't know where I would even start with this more complex obfuscation example, but that shows you just to what level obfuscation could go to. Now we're actually going to start covering manual deobfuscation. As you know, while a lot of automated tools exist and a lot of it very sophisticated ones at that too, sometimes you're going to be forced to do it manually. So it's important that we understand how to do this as well. So what I'm going to do here is I'm going to send you guys some scripts. This one's going to be a very simple example here. but it'll be one of our first, one of the first things that we do in de-obfuscation. Let's see, where is it? De-obfuscation, simple. So what I'll do is I'll post this over in stream questions. What I want you guys to do is I want you guys to decode it. I want you guys to say what is the useless function in this program and two useless variables. So two variables are just kind of added in there and don't have any purpose. I want you guys to go out of your way to remove the method that does not need to be there and remove the two lines that don't need to be there. So this is what the first example of our first step of code discovery is. What you're going to do is you're going to understand how the code works, and then you're going to go out of your way to get rid of all the useless code, which was used to pretty much beef it up. Identify non-code bytes, find missing symbols, look for instructions overlapping, and then find the functions of each bound, or find the bounds of each function. What you can also do is you can also use a control flow graph to reconstruct it. Building the graph noses and edges, you can identify the indirect control flow and non-returning functions. So, for example, if it got a, if you wanted to start off with like let's say in this case, for example, print statement, what we could do is we could look through everything and then we can try to figure out which variables are being used and which ones aren't, which methods are being called and which ones aren't. You can pretty much build like a control flow of that starting with the main or the first one that's executed. So you could start off with your var underscore 0xaf, follow that by the next variable that's being declared, follow that, and then try to understand where everything is being called. So I'll give you guys that first example. So what I want people to do is I'll give you guys about 3 minutes for that first example. I want people to copy and paste which function is the one that is not valid and the two variables that are unused as well. So in total, 3 things that you guys need to point out. I'll give you guys 3 minutes to do that. So once you find them, just post them into stream questions just so you can point out which ones are valid and which ones aren't valid. Don't worry if you're worried about being wrong. This is about learning. All right, so since it's been 3 minutes, I guess I'll do this. We'll go through together. Um, are you guys able to read my screen right now? Does this look legible to you guys? All right, perfect. So right now we see that we have two functions. We have var underscore 0xab and we have var underscore 0xa. So right now we can already tell that the function names are obfuscated along with the variables as well. What are the bounds of this function? We can see that it just returns the two variables that it takes in after you add them together. Same thing with the second one as well. And then what we'll go is we'll go over to the main method here. So we see right away is that 3 variables are being declared, which is 0xaf, 0xag, and 0xai. Each of them have a small alteration to them, but essentially the same thing. They're all declaring strings. So the first thing that we see right here is we see var 0xaf. So right now we know that this line over here has a purpose, which is good to keep in your pocket. Following that, when you go into the next one, we see print this method get, and then what we will see is it calls function var 0xab. One thing to note is that this is now the end of the program. There's nothing else to do. So now now knowing this, we can go backwards. So we notice that 0xag, xai will never be called in any circumstance. So what we can do is we could just delete that right there. Following that, we only see method var 0xab being used, so we can get rid of this method. And right away, we've already cleared up, a large portion of the program. So pretty much took everything that was just wasting time, and now we have the main things that we can focus on. What's actually usable. What we'll also notice is that this variable is only ever used to print. So what we could do is we could rename this variable. Since all what it exists to do is print a string, what we'll do is we'll just replace var 0. Yeah, I'll just move this up here. Var 0xaf, and we can replace it with we will call it print string. Once we replace all of them, we now have that we can work with. Next thing that we will go with the method is that we see that the bounds of this function is pretty much just returning the addition of it. So what we can do is we can rename this function to addition function. And right away already we have something that is a lot more readable. And with that being said, now we know the purpose of the program, which is pretty much just print a string and then it gets a method by adding two functions. And then what we could also do is you could also clarify this even more, as you could go with var 0xac. Since this is just one of them, what we'll do is we'll rename this into number 1, our first addition number. First addition number. Replace all of that, and then we could do the same thing with a second number. We'll look through that, see that this is, that it pretty much performs the same thing, except that it's the second number being used. So we will rename that. These are pretty long variable names, longer than they should be in this case, but right there, you have already cleaned up the program and you have de-obfuscated it. So now we'll go with something that's a little bit harder. The next one that we'll be looking at is this one over here. So what I'll do is I'll send this over in stream questions as well, and I'll give you guys 6 minutes for this one. So at 9:36, we will see what people's progress is on that so far. All right, so since we're not getting anything so far, I'll just manually go through this with everyone. So what we could do is we could do the same thing where we can look through our method, see that shift is the only one that's being used. Shift 2 and shift 3 are not used anywhere in the rest of the code, so that right there, you can remove those and you can get back to everything that you need. So looking through everything, we can see that v is used in length, so we can keep v here, knowing that that's good. New string is being used in addition with x and z. So what we can see is that y is no longer used, or is not used at all, so that's one line of code that we can remove. C is not used at all, so we can remove that one as well. And then what you'll notice is that x plus a is equal to a, and then z plus z is equal to x. So those are being used, but at the end of the day, they don't actually return anything to the program at all. Unless if these are being used specifically in its operation, you can essentially just get rid of them. So what we could do here is we could remove both of those, and we can get rid of them, their declaration, since we've pretty much determined that well, actually, no, we will need them over here because we can see y plus z. So what I'll do here is I'll go back to where I erased y, get rid of x, get rid of z, and because v is being used, we can get rid of c. So what we have left is we have y, we also have z, which I removed again by accident. So once we do that, 1, 2, 3, we'll have those. Look through that, get rid of anything that is being unused. In this case, that is these two at this point. So, and then what we come up with is this, and then you can do the same thing. Look over. We'll also notice here is that that x is actually not really being involved in anything. So what we can also do is we can also remove x as well at that point, and this will be what the de-obfuscated program will look like, and then you can work backwards, figure out what it's doing, etc. For the sake of time, I'll just skip all of the nitpicky stuff, and I will pass it on to Pablo, to Hashir, who will be talking about polymorphism.
Hello, hello. Can you hear me?
Yes, we can.
All right, perfect. Next slide. All right, thank you. All right. Hey everyone, I'm Harsher, and I'm going to be delivering the final segment of this workshop to you. We looked at encoding, obfuscation, and de-obfuscation, and now in this segment, we're going to be taking a look at polymorphism. Now, by itself, it sounds like a confusing term. Could you go back, please? Thank you. Now, by itself, it sounds like a confusing term, and upon actually studying it, you may see why. But the goal here today is show you some basic Python polymorphism and help you guys to understand the different ways polymorphism is actually done and talk about a polymorphic technique. So, next slide, please. Thank you. By definition, though, polymorphism means to take many forms. It refers to the use of a single entity, whether it be a method or an object, to represent different forms. Think of a chameleon. The chameleon has a polymorphic nature. It could take many forms and blend into the environment due to its polymorphic nature. Similarly, in programming, we see our entities such as objects take many forms. Basically, what this means is that it allows us to have many forms but still the same output. You can imagine these applications, polymorphic code that modifies itself upon executions to fit the environment. How it can be dangerous if it holds some harmful data. Another important thing to note is that polymorphism is one of the core aspects of object-oriented programming, which you will see in ISS in year 2. Unless you graduated, then you've already seen it. Next slide. Thank you. Something you should know about polymorphism is that there are two types, which you may see in Python, but from what I read, it's been associated with Java. A polymorphism that is resolved during compile time is known as static polymorphism. So this is the first type. Method overloading is an example of static polymorphism, or also known as compile time, which we're going to see in the following slides in depth. Now, dynamic polymorphism is a process in which a call to an overridden method is resolved at runtime. Method overriding is one of the ways to achieve dynamic polymorphism, which we'll talk about in the following slides. Just for context, compile time is a period when programming code is converted to the machine code, and runtime is a period of time when the program is running, and generally occurs after compile time. Regardless, both are types of polymorphism, and it just gives you a more technical view on it. So it's not that important as long as just basically, they're both polymorphism. Next slide. Thank you. All right, so let's look at example of an inbuilt polymorphic function. Now, from this, we could see that with the same function, we can provide different inputs, the main thing being their different data types, and being able to get an appropriate output from this according to the data type. So length is a built-in polymorphic function that allows different forms of arguments with the result being delivered the same as a number. The important thing to note here is that it's not polymorphic code, but it's a built-in polymorphic function. But through this example, we can understand how something like this function can have different forms but still be outputted the same. Next slide. Now let's take a look at another example of polymorphism. So let's take a look at this. On the right, we have the class bird and class ostrich. Now by itself, the birds can fly. It has a flight method stating birds can fly, and generally that's true. Unless stated otherwise, birds can fly to this program. Now we do know not all birds behave the same. Some sing differently, some eat differently, some may fly differently, which becomes less of a concern when we have an ostrich class. Because with the ostrich class, we can add our own personal attributes to it. But the main thing is that the ostrich can't fly. So that's something that needs to be stated. But looking closer at this ostrich class, we see that it inherits or extends off a bird, which means it knows everything in that class. Now, one thing in common are the flight methods. Pay attention to the two versions of flight that we see, one in the bird class and one in the ostrich class. What do you guys think would be prioritized when we run this program? Like, what would the output be? Let's see if we can get an answer. If not, we will move on. Looks like we're not getting an answer. That means we will move on. All right, so because ostrich extends bird, this code allows the ostrich to be treated like a bird, basically giving ostrich multiple forms, either bird or animal, for example. It is polymorphism because of its ability to take many forms and having the same output. Now, speaking of output, the output would be that ostriches can't fly. This code will prioritize the ostrich despite knowing birds in general can fly. Next slide. Thank you. Now, in the previous slide, we looked at an example of method overriding, which is what we also touched upon a couple slides ago. Now, method overriding is a feature which is also one of the 3 methods of how polymorphism in Java is achieved, but it allows classes like these, which has a superclass and a subclass, to still override the superclass. So to be clear, we see the subclass's method being executed over the superclass, essentially overriding the method in the superclass. Next slide. Thank you. The second method of the 3 is method overloading. It is a feature that allows a class to include 2 or more methods with the same name but with different parameters. So on the right, you can see that there are 2 methods called add, what do you call it? 2 methods called add with different parameters. And if we were to call the function at the end, which is supposed to be add 455, not product 455, that's my bad, it would have to run one of the codes, which would be the first, which would be the first method. Now this, sorry. Yeah, so depending on the parameters, when I call the method, I can get some are 2 or 3 integers. So this is the second way polymorphism is in Java is achieved. All right, next slide. Thank you. Now, this is the last way polymorphism is achieved in Java, which is operator of overloading, which refers to when the same symbol or operator is used for multiple things and come in different forms, depending on its context. So if you look to the right, we can see the plus is used for addition and string concatenation. So understanding how polymorphism is done in Java theoretically and showing you guys examples in Python practically, hopefully should give you somewhat of a grasp of this concept in terms of what you see in school or if you've already seen. But yeah, so very basic examples, but this is kind of how polymorphism is achieved at a very, very, very basic example in Java, which can be also done in Python that we just showed. Next slide. Now this is the main thing, which is the polymorphic technique. Now, the main technique which polymorphism is used for is self-modifying code, which, to define it, is any code that modifies itself upon execution. Polymorphic code is a code that mutates while keeping the original algorithm intact. This technique is sometimes used by computer viruses and computer worms to hide their presence. Interestingly, polymorphism was used for the first time to write the body of a virus and was meant to hide this body through encryption, kind of like behaving like a chameleon to be able to adapt to its surroundings to camouflage, which you mentioned much earlier. Self-modifying code brings a risk to the debugging process because it makes it far more complex. Because as time goes on, you wouldn't really be able to go back. It's going to be harder to go back. Advanced polymorphism allows it to take it even further because it provides features that complicate debugging and the reversing time. An example or 2 of the features can be encapsulating of complicated anti-debugging tricks or inserting a lot of junk and garbage into the real code. So yeah, the combination of these features result in a drastically elongated reversing time and complicated debugging. And that is why self-modifying code is very dangerous polymorphic technique. And combining the ability to self-modify with obfuscation even further takes the risk for how much damage can be done and how hard it is to reverse and figure out what the problem is. And yeah, it's quite insane. But yeah, that's a really dangerous polymorphic technique from a security standpoint. And next. All right, perfect. Oh wow, thank you. You're welcome.
So thank you everyone for sticking out this long. I know that this was probably one of the harder workshops that we'd be hosting around, since it's a lot of new information and a lot of very roundabout techniques. So yeah, thank you for sticking it through. Kurt has been streaming this entire time, so if you want, it'll be available on YouTube. If not now, it'll be later. But yeah, and pretty much it'll be on the ISSessions channel. So what we also want to hear is we want to hear your feedback. If you guys want to have any specific preferences for future workshops that you guys would like to see, and if you have any feedback on this one in particular, feel free to bring it out there at all. So again, I've posted the form for our feedback and stream questions. If you guys could just give us your thoughts on that, and let us know what you guys would like to see in future workshops. Thank you everyone for sticking out so far. If there's any questions, feel free to answer them. In the meantime, you're good to go.
Yeah,